This problem is from chapter 3, and we are going to practice choosing a formula and writing down the given information for this type of problem. So in this scenario, we have a skateboarder and she's moving at a certain velocity, and then she starts to go up a ramp or like a hill, and that makes her slow down. So if we had a picture of this situation, it would look like kind of like this, and she is starting off down here and she's moving along, but then it's a little strange because it talks about how much time is going to pass from when she begins to slow down, which I guess is the picture I just drew, until she begins to move back down the incline. Like she's just going to coast? That is so silly. Who does that? Okay. So I guess though she's just going to do this experiment where she coasts, not going to push off, just going to let herself roll up the hill and roll back down again. And when it talks about until she begins this moment, when she begins to move back down, okay, I'm going to put no whoosh marks up there. That would be the moment when she has a velocity of 0. Okay, so let's start writing down the pieces of information that we know. And okay, good. I also don't like it how they put constant velocity in there. That's really misleading because the velocity is changing. She might have been going a constant velocity before, but she will not be going a constant velocity anymore. So that's the velocity she had at the beginning. So that's what we put down for velocity initial. That's what the I stands for. And then, like I said, when she's right at this spot right here, that's when she's going to pause just for a moment. And that is the moment we care about, okay? It's not the final moment. You know, you're like, why is she writing final? She's gonna roll back down. But because that's the moment that we're trying to pause the problem at, that's okay for us to just write that down as the final velocity because we need to solve the problem for that period of time. And then they tell us the acceleration, and this time they're nice and they actually put the negative sign in front. Sometimes they just say the slows down at a rate of, and you have to figure out for yourself whether it should be negative or positive. But this time they give you the negative sign. And we are looking for time. They don't give us any distances in this problem. Okay, so I copied our formulas. They didn't copy too well here, but these are on your formula sheet, like the back of the sheet that has all the conversion factors. These are all the Unit 3 formulas. And in this chapter, you're going to use trial and error and figure out which formula to use to solve for the unknown. Notice we have no formulas that have delta t on the left-hand side, but that's okay because we'll just use algebra to solve for time. Okay, but we do need a formula that has only that as your unknown. Okay, so like for instance, if I just randomly picked this formula, okay, and I tried to see what I have in that formula, I don't know these distances. I do know the initial velocity, but I have too many question marks. I have too many unknowns. So this is a no-go. This formula here doesn't even have time in it. So I don't want that one. So if I check the other two, I have acceleration, I have initial and final velocities, and I am looking for like basically the change in time. So this is a good one. I could use that one. Let me check this one. I have final velocity, I have initial velocity, I have acceleration. I just don't know time. So either of, you know, these were big X's. I don't want to use either of those, but these will work. I can pick whichever one I want. Okay, so like let's say that I'm going to use the first one. So I would go ahead and write it out and say A equals VF minus VI, and sometimes I'm sort of just taking the delta T as a simplification of that denominator. And then I'm plugging and chugging, right, from my given. So I know that this is negative 0.20. And then I'm going to put 0 minus 1.75. Okay. And then I'm multiplying both sides by delta T. That gets rid of it on this side. And then by delta T on this side. So now I have delta T times negative, oops, sorry. And then I have negative 1.75 on the other side. And then just divide both sides by negative 0.2. Okay, so then I end up getting 8.75. Watch the units here. I'm going to cancel the m's, and then this is really, I get to do one of the seconds cancels, and notice I have really seconds in the denominator and seconds squared in the numerator because of this all fraction situation, okay? And then I check sig figs. Let's see here. I was okay on the subtraction step. Like 0 has a lot of sig figs, like stopped is stopped. So then I only have 2 sig figs in that acceleration number though, so I'm going to have to round this, okay, and say it's actually, let me give myself some more room, 8.8 seconds. Okay.